Which, okay, I've got a funny window on. Are you looking at homework 13? Is that what you're saying? Okay, good. Maybe I'll get away with one more in large. It helps me at least with my eyesight. Darn it. Just a... no, that'll work. Right, for each of the following research questions, specify whether the parameter of interest is a population mean, the population mean of a paired difference, or the difference in the means of two populations. Why am I thinking that's familiar? Have we done this before? Did we cover these questions? No, okay. So it must have been my stats class. So residents of a neighborhood have been complaining about speeding cars. The speed limit in the area is 25 miles an hour. The local police are monitoring the situation by recording the speed of 100 randomly selected cars. And then they want to know whether the mean speed of these cars is higher than 25 miles an hour. So they're getting some information, some data to try and prove that people are actually driving faster than the 25 mile an hour speed limit. So in each of these questions, what is the parameter of interest? The parameter of interest here is one population mean. I guess I would have said, isn't the parameter of interest here the mean speed of all cars in that street, right? Something like that. Now, refer to part A. After collecting the data described in part A, the police decided to install an electronic roadside sign which tells you how fast they're driving. I've seen those darn things. They are very annoying because they make me slow down. Because I think I'm traveling at a nice speed, and then the thing flashes at me and it says too fast, and then it says 40, right? You ever had that? That's what those guys are. So then they record the driving speed of another 100 random selected cars, and they want to know whether the mean speed is lower after the signs. So what they're really doing here is they've got some before data. This is what the average speed used to be, right? And then they put up this new flashing thing, you're going too fast, slow down me, Gizmo, right? And I'm assuming that they get the speed after that sign has happened, right? So they can actually, it has had an effect, and they look at it again. So can you imagine what you're going to have here is two different samples and you're going to compare them? Now, if they were the same, wouldn't that been, well, you spent a lot of money in that sign and it does nothing to the speed, right? They still go the same speed they were going before. I suspect what they'll find is that it reduced the speed, right? That people go a bit slower because they've been told. And in this case, aren't we looking for the difference between two populations? That is good evidence-based decisions, right? Governments aren't very good at doing evidence-based decisions, but that would be a good one, wouldn't it? Right? You get some data to see whether or not, you have a problem. Well, yeah, the average is about 29 mile an hour. That's too fast. Okay, let's stick up a sign. Now, a lot of politicians just stick up the machine and they walk away. Hey, I've done something, right? What they don't do is they don't check that it's actually done something, right? Has it improved? Well, that's good, isn't it? They collect 100 cars and say, hey, it's went down to 26. Well, at least we knocked a couple of miles off it, right? It's cool. Now, for each of these research questions, write down and define the notation that would be used, and the key word here is for the population. Which one of these guys represents the difference between two populations, means? Which one of those formula is the difference for two population means? You get 6 dots to pick. I see fingers pointing at 6. Would you all agree that guy? Define the notation that we've used for the population parameter of interest. So what does that mean in English? I guess I'll need to do the story now. Nutrition tends to have changed over the years, and this may affect growth. Researchers want to know whether the mean height of a 25-year-old woman is the same as the mean height of a 45-year-old woman. Okay. So isn't the population mean difference in the heights between these two women? Let me check the phrase of that. This is the difference between the population mean height of 24 and the population mean height of. This is correct. It's not that one. It's that one, isn't it? The other two don't make sense. Okay, you plan to fly from New York to Chicago, and you have a choice of 2 flights. You are able to find out how many minutes late each flight was for a random sample over a 25-day period. You have data from both flights on the same 25 days, and you want to know whether one flight has a higher average delay than the other. So I want to use Delta rather than American Airlines because Delta doesn't delay as much, right? Something like that. So what would the notation for the population parameter be? Actually, I'm getting deja vu here. So let you figure that one out. It's the same question, so I'm just letting that slide. Okay, new question. In each of the following situations, determine whether the alternate is the difference is greater than 0, the difference is less than 0, or the difference is not equal to 0. Now, normally you would get a little story in English, but this is different. They're telling you the null hypothesis, which isn't much of a help because isn't it always that? So we're not getting anything we didn't know. They are giving you clues. And the clue is the t-value and the p-value. The degrees of freedom don't help much, right? That t-value is pretty negative, isn't it? And if you have a t-value of negative, which one of these 3 is the one that tends to make negative t-values happen?
Less than 0.
And that's that guy. So do you see I'm just looking at the t-value and the fact that it's small? In other words, this guy is matching that guy. Now, just to show you things can be sneaky. Do you see that's positive? And do you see that's really big? So which direction do we go this time?
Greater than 0?
So you're going to go that way, right? If you did a t distribution and you did everybody to the right of that number, wouldn't the answer be very small? That one. That was sneaky. It's not just the fact that that is negative that made this less than. It's the fact that that is negative and the p-value is small, which is agreeing. And when the two of them agree, you pick the direction that it's going. But this t-value is positive, which makes you think of that. But do you notice that the p-value is huge, which is basically saying that's the wrong direction. You should have went the other way. And that's the end of that question. Now, the next one involves us doing calculations. So I'm going to have to just write the numbers down and then show you what we've got. So we are being asked to find the t-square. And I'm writing the formula down. You'll see it in a few minutes. It's x1 bar take away x2 bar, and then it's divided by the standard error of those two. So we are going to do this by hand, essentially a calculator, right? Now I know x1 bar, although you can't see it anymore, it was 39. I know x2 bar, it's 34. And I don't know the standard error, but I do have a formula for calculating the standard error. and it has a big square root. Can anybody remember what the formula for standard error is? We did it yesterday.
S1 squared divided by N1 plus S2 squared divided by N2.
Right. So I'm now going to put in the numbers and then do the calculation. S1 happens to be 10. So it's 10 squared over 100. And S2 squared happens to be, oh, they're just being nice to us, 7 squared over 49. And that ends up being the square root of 2, which is 1.414. I didn't actually need my calculator because the numbers were so nice. So that guy there goes 1.414. Then I go, and what am I doing wrong here? 39, take away 34, divided by 1.414, which is a huge t-score, which is that worries me. What have I done wrong there? Because that's not the right answer. $39 take away 34 divided by that guy. Looks right, but it's not.
A bracket?
Yeah, bracket. Oops, 39 take away 34, close the brackets, and then divide by 1.414, and there is roughly about 3.54, right? It doesn't mean that you don't get really big t-scores or really small t-scores, right? It is possible to get a t-score of 14.5 or minus 9.8. They are possible. I think yesterday, didn't we get some really big ones, right? And that's okay if it happens correctly. But if you're doing a question and you do see a really big t-score, well, you have a quick check that you didn't do the mistake that I did, right? It's an easy thing to forget a bracket. Well, that is the answer to that question. So let's return to the homework. So they want the answer to 2 decimal places, so I would do 3.54. Now, can you see in this question, they've only told us 2 numbers. They've told us the difference in the sample means was 43, and that the standard error of x1 bar take away x2 bar was 24. That's all I need. What do I need to do with those 2 numbers to find the t-score?
43 divided by 24.
Okay. Haven't they kind of made your life easier by telling you parts of the answers, the 2 top subtracted and the bottom guy? And whatever that comes to would be your answer. Now, in this question here, it's find the t-score, and all the information you want is in this table. Can you see that x1 bar will be that number, x2 bar will be that number, so that's your top. Won't you use these 2 standard deviations along with these numbers to get the standard error? You might think, what about these 2 things here? They are totally irrelevant and they've nothing to do with the calculations we need. They're just there. Do you want to see what that calculation looks like, or are you comfortable with me just talking it through like that? Do you want me to find the t-score for question 6 or not? That's kind of what I'm asking. No, we're good with that then? Feel you could just grab your calculator and do it? Works for me. Right, now, question 7. A set of body temperatures was taken of 100 adults at a blood donor sentence. And Minitab's just a piece of software. It's a bit like Salt, right? It's just, it gives you lots of information. And what this does is it does a 2-sample T procedure, body temperature, and a whole load of stuff, right? Population 1 is female donors and population 2 is male donors. So I guess they're looking at the difference in body temperatures between males and females. And for instance, there were 47 of the people they checked were female, and that their body temperature was that number. And for the males, there was slightly more of those, and the body temperature was that number. Is that accurate for the people who are in the nursing program? Is about 98 and 97.9 about right? Is this true that women's temperatures are a little bit higher than men? Is that typical? Is there any particular reason for that? Is it just body chemistry? It just is because it is.
Without
Okay.
sounding offensive, women tend to have a little bit more fat, so they insulate better
Okay.
because of
Right.
children.
Okay, I got you. So there's tons of information here. What we need to basically do is look at this and figure out how to interpret it, right? So give a null and alternative hypothesis using female take away male, right? And enter that if not needed. So I'm assuming that we're looking for, is there a difference between the two? So let me check in case they phrase it. No, it shows the result. Since they haven't given me any major clues, I'm going to assume that the null hypothesis is going to be, as it always is, so I'm not really assuming anything, is going to be mu. Oh, how do I get that funny little subscript 1 that I need?
Functions.
Okay, so you're in functions and hit that button. 1. Space. Move my cursor. Take away. Mu. Funny little button. 2. And it's always going to equal 0, isn't it? I don't even need to read the story to know that's the null. Isn't the null always that when it's a difference in 2? Now I can save my time a little bit by just doing a copy and paste. And now I have to figure out, and I might get it wrong because they're not telling me enough here, but I think that they're wanting probably to prove that the females are warmer, right, than the males. And the only reason I'm saying that is that when you look at this raw data, would you agree that that's bigger than that? And so I'm assuming that's the direction. Now, I could be wrong, but if I'm wrong, the only difference is that it would be not equal to, right? Would you agree that's the only choice? So I'm not going to prove it's less than because it clearly isn't. So let me just stick with that one. Can I hit? No, darn it, in space. Okay, let me do an answer on that because I really want to find out which it is. Oh, am I good or am I good? I screwed it up. Isn't it not equal to? Will you be generous with me? Would you agree that it wasn't clear what they were looking for as the alternative, right? So you're going to do a guy like that. You want to make sure, you know, if you don't get it right the first time, you do it the second time. So that's fine. Now, maybe I misread it. Maybe there was a clue in there that I wasn't aware of. How about this as a rule? If they don't tell you, well, we always assume that it's not equal to. So if they don't specifically say, can you prove it's bigger or can you prove it's less, right? That kind of phrase. If they don't have that sentence, well, we just assume that it always means not equal to. And, you know, based on that last answer, I think I'd probably end up being correct if I did that assumption. So, oh, of course I went and killed the poor thing. So I'll have to put it back in. And we saw that one, right? And the alternate is that they're different. right? They're not equal to each other. So that's another way of saying different. There we go. Has anybody, when they've done this, for instance, is it okay if you put an extra space in, or does it get annoyed? Has anybody done a question and, yeah, if you put an extra space, it doesn't care, or nah, you can't do it? Nobody knows. I guess you'll find out the first time you try it, since I don't have that button that makes it handy. Now, it says, part B then, what is the value of this test statistic? Can you see it there? So it's this fella. Now it says identify the numbers used to compute this guy. So we are looking at the first fella, which is the females. Oh, 98.302. Okay, that's a funny way of doing it. That one. Take away the guys, which is that one. This one was the standard deviation of the female, so 0.655. And this one was the other people, and the other people were 766. And that whole thing should equal, oh, I haven't done that calculation. Do you want me to calculate that and find out which one of these answers it is? Or could you just figure that out yourself?
I thought it was just the t-value.
Of course it is. Yeah, I was thinking it was just the bottom part. Right, so that's it. Now, it says find the p-value. So somewhere in here, there's a p-value and it's there. So it's really just a matter of looking. Right. P-value. As p-values go, would you agree that's nice and small? Isn't it in fact less than 0.05? Which means that we can reject H0, which means that the alternate is true. So haven't we proved that women's body temperatures are different from men's? So I suspect that's what this sentence is all about and what that's about. Now, if you go to question 8, can you see it's just a different story, but the same darn question? Right. And now, I believe, we hit our first hypothesis test from start to finish using SOLE. A study presented data given in response to the question, what's the fastest you've ever driven? And in the females, there were 101. The mean was 88.3. The standard deviation was this guy. 86 males asked the question. This was the average that they had said. Standard deviation is that. Superficially, would you agree that it looks pretty clear that males go faster than females? Which wouldn't surprise me in real life. We are going to assume that these represent a random sample of college students. We're going to use a significance level of 0.5, and there's your choices. Do not reject to null or reject to null. So I am now going to take that guy away out of the road. Can you see this fella? Right. Now, inferential statistics is where you want to go when you're doing a hypothesis test from start to finish, right? All the way through, as we are here. Inferential statistics. Which one of these do you choose for the storylines that we are doing right now?
2 sample T.
Right. And every single question that we're going to do from that section is going to be 2 samples, right? 2 sample means comparison. Now, the first people are females. and they were 88.3. And the standard deviation is 14.2. I'm reading this straight out of the question. And the sample size was 101. And then I go to the second one, and this is for the guys, and they were 107.3. The sample standard deviation was 17.3. And the sample size was 86. Are you okay that that's all the data about the women that you need to put in? That's all the data about the sample from the men. Does that seem pretty straightforward where the numbers are coming from? Now, we've got a hypothesis test here. If I assume, excuse me, that women go at less speed than men, I'll use that one. If I want to test that they're just different from each other, wouldn't I do that one? Now, based on the story that's in front of me, they ask, is there evidence that females right? Well, actually, they phrase it this way. Males go faster than females, but isn't males number 2? So if males are going faster than females, isn't that another way of saying females go slower than males? So that's it. Now, I would normally, and I am going to generate results, and essentially I've got a whole load of information I want, but really all I need is a p-value. But there's a box here that doesn't get used much, but it does get used sometimes. And it says assume equal variance. You see that? It's also, have you remembered that they sometimes use the word pooled data? You've seen that phrase. The only time you should click on that equal variance one, right, is if the question says the data is being pulled, right? If you see a phrase like the data is being pulled, click on that box. If they don't do that, the other situation that you should do it would be if the two standard deviations are virtually the same. They might not be exactly the same, but one of them can be 14.7 and the other one can be 14.9, right? That's close enough. Then you can hit that box. So if you want to assume that they're equal, you would click that box. If you're told that it's pooled data, you would click that box. If there's nothing obvious going on, would you agree that these are distinctly different? Then do what you would typically do. The vast majority of the questions are leave it alone. So generate the results, and the only number that's really useful is that one. Would you agree that p-value is less than 0.05? Well, time to make conclusion then. If it is less than 0.05, don't you reject the null hypothesis? And so women go slower than men. Now, as a homework question, couldn't you just click in that, get it wrong, click in that and get it right? But you're not learning anything, you're just guessing till you get it right. Now, one of the things that's going to happen, kind of pre-warning for what I'll talk more about tomorrow, is that your final exam is going to be a bit different. I'm going to give you questions where you would get that story and you would use SALT. But if I don't see those numbers, because what the question will do is I will do an empty version of this so that you can show me the numbers that you put into SALT, right? And the reason I want to do that is if I just left that question like this, couldn't you get a 50-50 chance and just guess it right? Because I wouldn't know anything that you used. Secondly, can you imagine you typed in 1.7 when you meant to type in 7.1? You know that happens. Wouldn't you get the wrong answer? And I wouldn't know that the only reason you got it wrong was you typed in the wrong numbers. So you're still going to be using salt. Do you see the difference is that you're actually going to be writing down what the numbers you put into salt are so that I can use that as a check that you're doing it right. So if you screw up, can't I still give you at least most of the points if the only thing you did was, oh, you got the males and females in the wrong place? Or you typed in 1.7, but you really should have typed in 7.1. You did everything else right, except that. So don't guess, because if you get a test question in the final, you won't know what to do, right? Well, here is our next story. A study was conducted in which sedentary men, is that a fancy name for saying couch potatoes? Right. Should I be offended by being called sedentary men? Okay, I'm not offended. No, that would be anyway. They were randomly assigned to be, oh, come on, that's not nice. To be placed on a diet or exercise for a year to lose weight. 43 of the guys were put on a diet, while the remaining 48 were put on an exercise routine. The group on the diet lost 7.1 kilos and the standard deviation was 3.2. And the men who just did exercise lost 3.9 kilograms and the standard deviation was 3.4. Okay, so we get two populations. Those who were put in a diet to lose weight and those that were told to go jog 5 miles, right, whatever. State a test an appropriate null and alternate hypothesis to determine whether the mean lost weight under these two routines for the population of men similar to those in this study. And can you see the word that I mentioned earlier? You see the pooled? Isn't the only going difference be you'll check that mark, that little box when you come to do the question, right? Now let population 1 be the diet people and population 2 be the other one. And I'll start off with my mu1 take away mu2 thing. I just thought of a quicker way of doing this. Couldn't have copied the answer from an earlier question. That would have been quicker, but too late now. Okay. Now, they don't phrase anywhere that I can see that we're trying to prove that one is bigger or less than the other. So I'm working on the assumption that it's not equal to, okay? So unless I've skipped by the bit where they say prove one is better, you know, bigger or less than the other, I'm going to go for that they're different. And now the moment of truth. Question 10, let's find out. Am I good or am I good? It is not equal to. So remember that rule I said, if they don't mention anything, just make it not equal to. I think that rule's working. Now, I've got all that information. I know I've got the answer there, but let's pretend I don't. And I've got to move some windows around for a second. Let's show you how to set up all of that information into here. Well, we already got that set up. The first group of people are going to be, oh darn, it's too big, I can't read it. I'll have to shrink it. Right. Let's see what we got. I started 33 replacing that. So there were 43 people on the diet, and they managed to lose 7.1 kilos. And the standard deviation that they had was 3.2. And those who were in the exercise didn't lose quite as much. They lost 3.9 kilograms. Their standard deviation was 3.4. And in that group, how many were aside? 48. Are we comfortable about those who do diet and those who did it? Now, they mentioned in the question, use a pooled test. So that means click on that box. Are we good? Okay, so let's generate results. And the p-value is that guy, and there's some other things that we need to do. So let's kick back to here. Can you trust me that that guy is 4.61, which he is? That the p-value, did I do the right fella there? Right, I forgot to put the not equals in. Yeah, the p-value is less than, well, it's 0.00013 to 4 decimal places, is that? So yeah, they do agree, good. Now, is that number less than 0.05? Yes, it is. Can you see that you would reject H naught? But I jumped around a little bit there, but could you follow me what I was doing? I was taking the question, plugging the information into SALT, essentially getting whatever numbers they asked for, t-score and p-value in this case, putting it in, and then picking the appropriate conclusion using the p-value of essentially 0. Okay, right, I don't have time to do this the long way, but since the answers are here, let's cheat. Can you see this is a study where they're looking at do students in Pennsylvania sleep more than those in California? And here is the data. 174 Californians, that's the average sleep, that's their standard deviation. The Pennsylvanians, that's how much there were in that sample, 191 of them. They sleep a little bit longer, and their standard deviation is that. The difference is 0. The difference is that they're different, right? They're not equal to. If you went through this, the test statistic ends up being that guy, and the p-value, can you trust me, ends up being that guy. Would you agree that is not that interesting? Isn't the p-value not less than 0.05? And boom. And fail to reject. And perfect. We are finished. There is nothing new to do. And there wasn't any fireworks or explosions or anything, unfortunately. It would have been nice if we'd finished on some really spectacular question that got you thinking, but we just found out that there isn't any difference between two groups of people in two states and how much they sleep.